Okay, hi everybody. So welcome to Friday. Congrats on finishing up the first official week of e-learning with attendance and all that, and I hope you have a good spring break. So what we're going to do today is kind of a quicker day. It's a little bit shorter, less involved. So what we're doing again is still using kinematics to prove or debunk a claim that's made in a different popular movie. So this one is one that maybe more of you have seen. Hopefully you watched Napoleon Dynamite over spring break though, if you can get your hands on it. So what we're doing today is we are looking at the situation that we want to analyze. I'll kind of run you through how I got all my numbers for this analysis, and then I'll show you the Google form, and then that's what I'll have you turn in, is this Google form that has a bunch of kinematics questions built into it. So what we're looking at is this scene from The Incredibles. I won't talk too much about the background of the scene because it's oddly dark for a Disney movie. But so we have is this man, and he is falling off of a building, and we see Mr. Incredible. He realizes that he's falling, kind of runs back, jumps, and saves the man. So cool. So we have that scene. And what we want to think about is pretty much boiling down to, is this scene realistic? So is the amount of time it would take for Mr. Incredible to reach the man, so the ramp up from him running to the jump, equal or less than the amount of time it took for the man to fall that distance? So if it is too much time, if it takes him too much time to do that, then the scene's not realistic. But if it takes less than the time for him to fall, then it would be realistic. He would have enough time for him to run that distance and then jump in the air and catch the man. So that's what we want to look at today. Is this scene realistic? So I got a bunch of data from this. I don't know if you can tell. You'll be able to see from me looking at this. I'm kind of bored during this, so finding something to do with my time. So the first data point is the man falls at 94.48 meters. I want to run through how I got that. So I went and I looked up some official data about The Incredibles. According to official sources, Bob Parr, or Mr. Incredible, is 6'7", so he's 200 centimeters in height. I don't know where they got the official source from, but whatever, he's 6'7". And then there's no good scenes of Mr. Incredible kind of standing next to the building. He's all too far away. But there's this one good scene of Buddy, who you'll see later in the movie is not his buddy so much. But Buddy, he kind of lines up just below Mr. Incredible's pecs. So I'll show you in a second. We have this nice scene of Buddy standing in the window. So he lines up just below the pecs of Mr. Incredible. So kind of just below that line. So what I did was I kind of made a height ratio, and I used a ruler to measure out about that line of below Mr. Incredible's pecs. So if he's 6'7", I measured that to be 5 inches on my screen with the ruler. Just below his pecs was 2 inches and 2 and 5/16 inches. Then I set up a ratio and found that in real life, Buddy would be about 3.86 feet tall. And I'm using feet just because I don't know why. Whatever, I convert it later. So Buddy's about 3.86 feet tall based on these height ratios. And then we have this nice scene where Buddy is standing just in the window that they just crashed through. So I measured it in Buddies. I said, okay, if this is 3.86 feet, we got about 1, 2, and then about 60% of a Buddy. So you got 3.86 plus 3.86 plus a little bit more. So we get a window pane height of just about 10 feet. So it's about 10 feet when you do all that addition. 3.86 plus 3.86 plus 60% of 3.86 was just about 10 feet. So I said, okay, let's just say that they standardized that, made that a 10-foot ceiling. And when we look at it in this video, that's kind of half of a pane. So we have like the short panes and then the longer ones. So that 10 feet is about half of one of these longer panes. So I counted out how many short panes we have and then long panes. And I found that from where we can see, it's about 280 feet to the top. So 280, so 28 of these panes plus the half panes. And then I said, well, he's not jumping up this high, so there's probably some below it. This one was slated to be a short pane, and then we have a long pane, and they crashed through a long pane. So I just kind of assumed we have one short and then a long, so half and half. So 310 feet total is how much I'm assuming that the man falls, which is then converted to 94.48 meters. And then the horizontal distance, so from the building to horizontally where they end up, I couldn't find any good angles to really measure this from, so what I did was just went to Google Maps. I said, well, they're not in New York, they're in like, I don't know where they are, whatever. They're in some city that kind of looks like New York. So I just kind of found the block length of one random street in New York is about 50 feet, which felt like it would be standardized. So then I just called that 50 feet or 15.24 meters. And then the last part, or not quite the last part, but almost. In the video, we can kind of count out how many strides it takes for him to reach the edge of the building. So he starts from rest, and then it takes him exactly 5 steps, or 5 strides for him to go from rest to the edge of the building. So that was 5 strides. Then I looked up how can you calculate your average stride length based on your height. So you can multiply your height in inches by 0.413, and that'll tell you about your average stride length. So I did that. Mr. Incredible is 79 inches, so his stride length is about 32.627 inches, which then times 5 is about 13.6 feet, and then I convert it to meters. And yeah, so now I know how long it took him to ramp up, the angle I approximated, and then the mass. They also, official sources has told this person on Google, who's part of like the Disney wiki page, that he's 158 kilograms. So what this eventually boils us down to is this situation, where we have the man up top who is falling the 94.48 meters. We have Mr. Incredible who's launching himself with 30-degree angle, and he's going this 15.24 meters. He kind of has to ramp up for this 13 feet, which is 4.145 meters, and he's got this mass of 158 kilograms. So on the Google form, I kind of split this up into parts where we want to figure out, is this realistic? Would the amount of time for him to go from here and then leap be less than or equal to the amount of time it took for this man to fall the 94.48 meters? So I split it into parts. It's a little bit tricky, but we can do it with our kinematics skills and thinking about those kinematics equations. I'll also post the equation sheet with it because we may need to use at one point that one equation that we don't use too often, but it's still a kinematics equation, it's still useful. So yeah, so I kind of broken into parts, and I'll have you kind of keep track of your work and then upload your work at the end. But yeah, have fun. Hopefully this is a nice little realistic problem and a little bit less work, hopefully. And yeah, you have a good spring break, and I'll talk to you. All right, bye.